So yeah, hopefully that one was pretty easy. That's just x squared minus 4x minus 21. So get x minus 7x plus 3, 7 and negative 3. That one, recommend you do the diamond, then the box, or whatever other technique you use for factoring, but that's what I prefer. A times c up top, b down below, find two numbers that multiply negative 30, add to negative 7. Put the first and last terms, lower left, up, lower right. Sorry, upper left, lower right. And then, of course, the split terms, that's why we do the diamond. To figure out how to split the middle term, factor along each row. But because you're being asked to solve, you got to take it a step further. You can't just stop at the factoring. You got to take it a step further and solve. Why do we factor? Because anything times 0 is 0, right? So 3x minus 2 could be 0, or 5x plus 1 could be 0. Solve each linear expression individually, and you should get the answer. That's why you solve by factoring, right? Also, what else was I going to say? Quad form. That's pretty straightforward. It's right there. Not that hard. Just plug in numbers. You'll have an option to use quad form on the assessment today. Yeah, just figure A, B, and C. But remember, everything has to be on the same side first. You gotta get 0 on one side, all the other terms on the other side. Identify A, B, and C, substitute into the quad form. It will be provided. You don't have to memorize it. It will be on the test today. Oh, it's not on here. I'll put it on the board. Okay. Oh, thought it was on here. All right. I'll put it on the board. Naming stuff. I mean, there's lots of possibilities. Those are some of them. Pretty straightforward again, right? Solving. So if you have a cube root, make sure you raise both sides to the third power, because that's the opposite cube rooting, and then just solve for x. For 11, if you have a square root, isolate the square root first. Don't start squaring both sides right away because you don't have it isolated, because it gets really messy if you do. And you can't square the radical in 5 separately. You'd have to multiply the expression by itself, and it gets really messy. So don't do that. Move the 5, divide 3, then square both sides. That was kind of a doozy. That was a little tricky. There won't be one like that on the assessment today. But we talked about when we were on the board, on the walls outside, HG and GE add the whole thing, as well as HF plus FE. So you can kind of set up that way and then substitute for each of those segments and then solve for x. Once you solve for x, you can put it back into the GE expression and solve for length of GE. And I think many of you guys did that just fine after I helped you guys out a bit. Definitely I'm asking this for sure. I think I am. Yes, I am. Notice all I did is I just did Pythagorean theorem, right? That's find the distance, pretty simple. Like for GH, I drew the legs, 9 and 2. Did Pythagorean theorem, not that hard. Like it was a KL and OP and IJ and MN. So midpoint is the average of the X and Y coordinates for each endpoint. That's all you gotta do. So G and H, like for example, -8 and 1, halfway between is -3.5. The distance is 9, half of 9 is 4.5. So you go 4.5 away from each endpoint for the X coordinate. For the Y coordinate, that's pretty easy. Between 6 and 8, 7, not that hard. So that's how I just kind of like visualize it. Yeah, wait, Wagner?
I got the same answers, you just without.
Because a squared plus b squared equals c squared, and you have to square it afterwards when you do Pythagorean theorem. Or the distance form is d equals a square root. What you're doing is you're giving me the side squared. You got square root. Sometimes it comes out as a perfect square. If you get lucky, could happen. But the rest of those are just all right there. And I already posted this to Schoology as well as part of the homework. That one, don't worry about. It's a really messy diagram. Drawing two planes that intersect, you're gonna have to, I use like dashed lines to show like one's going in the page, one's going out of the page. I put plane alpha on the page. Yeah, it's kind of funny. And then of course, if you have two lines that intersect at point X, all lying on the plane, I just did that. So I put points A, B, C, D all on the plane and had intersect. Slope, pretty easy. I am asking this for sure. Find the change in Y or change in X. Be careful with the negatives. And use point slope form. Point slope form is Y, and it's actually on the test today. So y minus y1 equals m times x minus x1. You could have done negative 3, 5 for your x1, y1, or 4, 9 for x1, y1, your choice. We are going to ask you to label stuff, kind of like in this way. So, like which one of the vertical angles, or sorry, 1 and 3 are vertical angles. 5 and 6 form a linear pair. 3 and 7 are nothing. I mean, they're adjacent angles, I suppose, but not adjacent, but it's just part of a triangle, whatever. 2 and 4, of course, are vertical. Definitely we're asking something like this. Pretty easy. If they're corresponding to equal, if they're on the same side interior, they have to 180. 19, they're alternate interior. 20, alternate exterior. So those are equal as well. Should you get 9 and negative 8 or 7 and 5? We are asking solving a system of equations. So we are going to ask you to do it by elimination as well. So yeah, just find what x is, or y, whatever you want to do. But if you get rid of x, multiply the bottom equation by 2, x will cancel, add the equations. You should get 7y equals 7, y equals 1. Plug back into the equation, get x. You get x equals negative 2. Back into button. It's up to you. What if I multiply the bottom equation by negative 2? I've got positive for us. Then I've been subtracting. But what would happen? That would have been negative 4y. So I've been doing 3 minus negative 4, which is still 7. Negative 5 minus negative 12, which would have been 7. You see how it gets a little crazy, all the negatives? So I prefer to deliberately make this opposite of sign, but the same number, rough, like 4, negative 4, right? Then I can add them afterwards. Yeah. But it just depends on how you set it up. It's your choice. Just depends how you started. I started in such a way where I was intentionally going to add. You can intentionally subtract if you want. 22, I think we'll ask something like that. I don't know. Actually, we're not, but you should know what to do. Identify the slope. So get y by itself, identify the y-intercept. Pretty easy right there. So this was pretty good. Any questions? No? All right. So delta math, I have it queued up. We already did a problem like this one. So you can look at the delta math here. I put a lot of different topics. So what we'll do is we'll kind of go around the room and I'll kind of prompt you and kind of have you guys help me out. And then afterwards, I'll have you guys just get your laptops out and just work on it. And I'll walk around to kind of help you guys out. And you can pick whatever you want, like whatever you feel like I really need more work with this topic, you could do that. So it's a whole, like if you feel like I'm cool factoring, I don't want to do that, but I really need help identifying triangles of a given type, right? Actually, the more I think about it now, we probably should go through each topic here because this is pretty comprehensive. So we'll kind of go around the room, I'll kind of prompt you, and then we'll do some work on your own. So we'll start with this one here. Whoa, that was level 1. What? Oh no, I picked the wrong one. I wanted this one. Here we go. It's like, whoa, okay. All right, here we go. Oof, a little easier. So you'll see one that's kind of that simple. So Adam, thoughts? How can I do this?
Yeah, you do the diamond thing. I don't know.
You tell me.
Project.
Or we're just factoring though.
Oh, we're just factoring.
Yeah.
Okay. So you do 4, 4.
Great. And that's it. Because when the leading term is x squared, it factors that nicely. So what I do is I find out what the last term is, I find what the middle term is, what multiplies to the 16 and adds to the 8, right? So that should be pretty straightforward. Okay. Okay, Wagner, now I'll give you a tough one. All right. Ooh, that's a tough one. Okay. So I'm going to do this first. I'm going to kind of get you set up here. What two numbers multiply 60 and add up to 23?
23.
If you ever get stuck, start with one in itself and start whittling your way to the middle. Trust me, if I'm gonna tell you the factor, it's gonna factor, right? So 1 in 60, 2 in 30, 3 in 20. Right, we stumble upon it. Now, some people have their own techniques. I prefer this technique. So what I do is I put the 5x squared in the upper left corner. I put the 12 in the lower right corner. And the whole purpose of the diamond is to split the 23, which gets split like this, 3x, 20x. Now, if you look at the first row, Wagner, what's common between 5x squared and 20x? Yep, and x as well. And what would you multiply 5x to get the 5x squared? Right? Then what am I going to put right here? And then finally right here. Perfect. So good team effort, 5x plus 3, x plus 4. And that's it, it's factored. Now, sometimes you might have a common factor. I don't know if I had that anywhere. Yeah, I don't think I had that, but do be mindful. Let me go back to that one more time. What if this were, I'm just going to rewrite this as a new thing. Kind of new thing. Okay, so you have 10x squared plus 62x plus 60. Do you see a common factor among all three terms? Two. You pull it out. So make sure you do that first if that were a possibility. So look for that, just so you know. Okay. Peter, let me have you do. Okay, back to this again. Okay, we're asked to solve. So what should be my first step? Correct. Yeah, always get everything on one side. Okay, and then this should be a pretty simple factoring. What multiplies to 10 adds up to 11? Perfect, thanks so much. So you have x plus 10, x plus 1. But you're not done yet, right? Because you're asked to solve, not just factor. We're always the opposite, right? Correct. Good. Good. Okay. And that's what your report is your answer. Good. Okay. All right. So now let's try another solving one, but this one's going to be a little bit more challenging. Okay. So now what should be my first step? But before we do that, everything should go. Yep. It actually wants to subtract. It wants to subtract. Sorry.
Okay.
And where should
Also 7,
perfect.
0.
Good. Then we put negative 14 up top, right? Because you do a times c. Now we gotta find two numbers that multiply to the top and add to the bottom. What would those be? Excellent. 7, negative 2. Remember, we still do our box. And remember, I always put the first term upper left, last term lower right. 7x, negative 2x. Okay, what can you take out of the first row? What do they both have in common, those first? 2. And what else? Correct. And then what do you multiply 2x get to 2x squared? Right? And then we get perfect. And we're almost there at 1. So you have 2x plus 7, but you're not done yet because I'm asking to solve. So you have to see what makes each of these 0. So that would be x equals 1. And if you subtract 7, divide 2, you should get that. Okay, so that's just want to make sure we're cool with that. All right. All good. Okay, thank you guys. You guys are being very helpful. Let's now move on to Athena. What do we got next? We got quad form. Okay. Okay. So I'm just gonna you're gonna talk me through it, that's all. So what should be my first step?
We should probably so it should be like x equals 12, not negative, just 12.
Yeah, let's move the 3M over first, just so everyone. I know what you're correct, but I just want to just make sure everyone sees what we're doing. So you move the 3M over, right? Okay, cool. So right, so you have 12 plus or minus.
Negative 12 squared.
Which you get a calculator.
4 times 5.
Perfect. All over.
2 times.
Right. Then I'll ask you to kind of just carry it over. I mean, keep going. So if I keep going, it's terribly exciting stuff. All right, 12 plus or minus. 16 times 5, that's 80. Yeah, so you get 64, I think, inside. So you get 12 plus or minus 8 over 8. Whatever you do, do not cross off those 8s. You got to do each one individually. So 20 over 8 or 4 over 8. So it's 5 halves or 1 half. Okay, 5 halves or 1 half. Cool. All right. Okay, just another quad form problem. I'm just going to show you the solution key because I think you guys get the idea. This one comes as a little funny, but notice how we add 6b squared. You get that. And then we do the quad form. You get this and does not simplify. That could happen. That's definitely a possibility. It may not simplify. And you leave it alone. So just keep that in mind. All right, Kelsey, let's have you do naming. Now I'll get some geometry. I don't know what this looks like. Okay. Oh, the answer's shown. All right. Let's get a new one. Here we go. Okay. So first of all, is it a line, a segment, or array? Okay, great. So it's a segment. So we're gonna use this symbol. And how can you call it? Yeah, that's it. Or that's it. Yeah. That's simple. So
Wait, if they, like, single arrow points in a different direction, does that mean something else? If the arrow points that way, if it points that way?
yeah, it'd be array. Yeah, so what if I had this here? Actually, let's try another one. Because I think this one had array.
Like, does the way the arrow on the ray, it's like when you write the symbol?
It would. I mean, like let's say I want to write UD. I have to put U first and then D as a second letter. Obviously, this is a lot. This is a line. Let me see if I get array. So because you're asking that question, let me see if I find a. Yeah, here we go. Perfect. Yeah, so this is clearly array, right? So we know it's going to be this symbol. And now we're starting at C, right? So you can say C, J, or you can say C, B. You don't want to say JB because it doesn't start at J. It starts at C. So you got to identify the starting point. Well, because the CJ still goes through it forever, so we'll include B. Or if you CB, then J will be. As long as J and B are both included, it won't matter because going forever in that direction. But both are acceptable ways of writing it. I wouldn't, if you did either one, I don't care. But that's what they want. So hope does that kind of clear that up? Yeah, okay. Okay, cool. Hey, Bella, let's try this here. This is a pair of lines, I think. You got this. Okay, so these are parallel. Okay. So hold on a sec. So what's this going to be right here? Oh, it's hard to read. Okay, let me expand. Sorry, my apologies. What? Won't expand. Hold on. It's 5x plus 3. Geesh, hold on. Hold on. I just messed up my screen royally. Okay. What did I do?
What is that?
Okay, I don't know what I'm doing. Anyhow, this right here. Wait. What? Hold on. Let me refresh this. This is being stupid now. Here, let's refresh. Okay, save prompt still. That was really weird what was going on. Okay, it's clear. All right, so okay, so this also has to be 5x plus 3, right? Because it's directly opposite of this 5x plus 3. So how would I make an equation with these two here? If we're on the same side. Correct. You add them up, say equal to 180, right? Now, if they are all to interior or corresponding, you make them equal to each other, right? So we don't set these equal to each other. We actually set A equal to 180. Right, whenever on the same side, but you had to identify 5x plus 3 is opposite. So 6x plus 6 equals 180. I know you guys can do the solving, I'm not worried about that. And I think that's 28. No. 29. 29. Yeah. Yep, 29. And just to kind of just so you guys see one more, how are these related if it's set up that way?
Same side.
But they're corresponding. They're not interiors. So how would I set add them up and say equal to 180, or do they equal each other? They equal each other, right? Exactly. Because they look the same, right? That's the other thing too. So 5x minus 8. Plus, I think you get a really weird answer if you add them up equal 180. So you get x equals 16, which means this would be 72 degrees and also 72 degrees. So okay. Ellie, what is going on here?
Can I get water?
Sure, go for it, yeah. Hold on, it's acting really slow. Delta is so slow. Okay, we got skills. Okay, so we did transversals. Let's do this one next. Okay. So what do you think B and C would equal, Allie? So we'll start with B. So if that's 142, what do these two add up to? If they form a straight angle? 180, perfect, good. You solve it. So what would be equal in this case? 38, got it, good work. And then wouldn't C be the opposite, same thing, right?
Yeah.
Yep, so there we go. 38, 38. Okay, well, you guys get the idea. Yeah, it's really slow. I'll go back. Level 2, these are a little more challenging. Oh, good one. Okay. So Adam, what do you think X would equal, and then what would Y equal?
This is 90 minus 41.
Good, which is 49. Now Y.
Y is, wait, so X is 49, so Y is, are we assuming Y and X are 90?
Exactly, yeah. Yeah, it's kind of hard to tell. So that's another right angle right here. That's the right angle. So see how that's a right angle?
Oh, it's also.
So X must be 49, but Y is 41, right? That's why you should practice a little more of this. It's okay. We'll have some time. So maybe you want to gravitate towards this. This might be a good one to once I finish going over this. So do a little more practice. So this is vertical adjacent contour angles level 2. Okay, let's do another one with parallel lines. That doesn't seem too hard. Where?
Yeah. Down the middle.
Oh, it's distorted. Oh yeah. That's weird. Hold on, your screen. Hold on. Yeah, it's the optics of the projector. Well, this one's kind of hopefully pretty straightforward. These have to add to what? Correct. Yeah, so X plus 54 equals 180. And that's going to be 126. Yeah.
They equal 180 if they're both inside the tree now.
But this case they're just they're right next to each other on a line.
Oh, because they're
Okay. These are they just form a straight angle. Yeah, this is actually I don't even know why they put it under parallel because that didn't do anything with parallel. Had nothing to do with parallel. Okay, this is a little better. So we recognize that this is going to be 5x minus 4. And that's going to be 9x minus 12. How do I know that? Because of vertical angles, right? Now, that's what you're talking about, Kelsey. When these are same side interior angles, these are interior and on the same side. What do these two add up to? Correct. And that can solve for x. Once I get that, then I get y afterwards. So you'd add them up and then solve for x. And then once you get that, then you can figure out what y equals. If I do that really quickly, it's 14x minus 16 equals 180. 14x equals 196. X equals 14. So that's 114. So it's 66, I think. 90. Yeah. Don't know if I'll ask this question, but it's kind of good to talk about in terms of terminology. Linear pairs. Linear pairs are two angles that form a straight angle. So PSL, which is right here. So here's PSL, guys. PSL. Okay, that's I'll do this. Okay, what angle? So I help this one. What angle is right next to PSL? So PSL is right next to P. Let me do the board actually. PSL.
Oh,
That's PSL, right?
Yeah.
So what angle is right next to it?
and, well,
That's it. That's your linear pair. Yeah. You say NSL or LSN. Either way. That's a linear pair.
it's just with the S in the middle.
Correct. Right. So I have NSL. NSL. Oh. Oh, you have to get the that's stupid. Whatever.
Wait,
They want you to put the angle number. What angle number? Stupid. My answer is wrong. No, I'm not wrong. Here, let's do one more just for redemption. All right. Oh, vertical angle. Okay, so UXR. UXR is right here. Okay, so yikes. So yeah, definitely UXR is like this. So see how angle 3 is identical to UXR. What's directly opposite of it? So I should write angle 1, right? I wrote the actual angle number. It's just being stupid. Here we go. That much better. Okay. Okay. Just make sure to just know the terminology. That's really what we're talking about here. I don't think I'm asking this, so we could probably just forego this one. Yeah, let's just forego it. Yeah, because there's no diagram either, so we'll just forego it. Sure, go ahead. Actually, I'm gonna remove it while I'm at it. And see if this one. Yeah, that's a good one. Okay, so if you think about it, this is 90. And you have these two other angles here, right? What do all three of these add up to? Correct. So 9e plus 90 plus 5e plus 6 equals 180. And then you can solve for e after that. So that's a good one. Okay, why is it doing that? Ooh, this is a good one. Yeah, so yeah, if you have 2 points, I strongly recommend you plot the points. So Peter, if I did this, how long is each leg? Oh, let me erase this word. Yeah, what else? Is it 6? No, it's not 6. 4. Yep, 3 and 4. So if you do Pythagorean theorem, you get 25 equals c squared. C is 5. Yeah, cool. Okay, and Pythagorean theorem is on the test, just so you know. So that's how I'd handle distance formula. Midpoint.
Except for finding distance. Midpoint's different, but like, I thought with the distance one, the formula was like it had a radical include.
Yeah, that's because it takes the Pythagorean theorem and takes it a step further by isolating the hypotenuse.
So
It's up to you. It's your choice. So remember, Pythagorean theorem is this, right? If you think about it, the c is like the distance, the a is like the difference in the x's, and the b is like the difference in the y's. These are exactly the same thing. Because when I draw the 2 points, right, and I have this here, that's A, B, and C. See how A is a horizontal leg? A is the difference in the x coordinates. B is the difference in y coordinates. It's the same exact thing. The hypotenuse is the distance you want to find, same exact thing. And then why do I have the radical? Because I get rid of the square. But see, if you can't remember, it's just so many things going on in this formula, right? Because all these are the letters. You can always rely on this. It's the same thing.
it's a good connection.
Yeah, now you see it. Good. I did my job. I got my money worth today. All right, I got paid. All right, good. Good. Yeah, that's what's happening. Yeah. Yeah. Anyone, I don't care. And both are on the test. Both are on the test. On this assessment today. Here, midpoint. You can just plot the points, like kind of roughly say, 7/10s here, 2 5s here, you know, whatever. So here's 2, here's 7, here's 5, here's 10. Okay, not the straightest line. Okay, what's halfway between 2 and 7? Or add them up, divide by 2. It's gonna be a fraction or a decimal. What's 2 plus 7 divided by 2? 4.5. So that's 4.5. What's half between 5 and 10? Add them up, divide by 2. 15 divided by 2. 7.5. There we go. So 4.5, 7.5. And by the way, that's exactly between 2 and 7 and 5 and 10, right? So that's how you find your midpoint. And we give you the formula anyway. So that's midpoint. What else we got here? Okay, this is a good one. Okay, I'm definitely putting a problem like this on our assessment. I'm not, it's there, but so first off, we have 3 types of ways of classifying the angles: acute, right, or obtuse. And I will kind of ask you to kind of do it that way. And then based upon the sides, scalene, isosceles, or equilateral. Okay, let's start at the angles. Do you see any right angles here? Nope. Are all the angles less than 90?
No,
Yep. So it's obtuse.
knuckles. Oh,
It's obtuse. Okay, sides. Are all the sides the same?
no.
Nope, side equilateral. Are 2 of the sides the same?
No.
Nope, not isosceles. So therefore it's scaling. Correct. So scaling, obtuse. There you go. So that's how you do it. I know when we had it on the assessment, the pre-assessment, you guys were a little stuck on that. But yeah, that's it. Let's try one more, see if you guys can get it. Okay, I'll leave the labels up here. So be very, very methodical about this. Okay, start with the angles. Which of those two is going to be? The right angle. How many sides? We have two sides the same.
Oh, yeah, we do.
That's also right.
Sweet. What is there?
4.2, 4.2. Yep, Saucy's right. So don't overcomplicate it. Notice I was incredibly methodical about it, right? Just angles, sides, put it together, right? Make it simple. Because we care about that. Drawing triangles, I don't know if that's really something we want to. It's good little extra practice, I suppose. Like if you want to make it acute and isosceles, okay. Acute, isosceles. All right. That's good practice, I guess. Anyway, we'll leave that there. Okay, identifying polygons. We've had this before. Okay. How many sides does this have? I'll start on the far left. 1, 2, 3, 4, 5, 6, 7, 8. The 8 sides. And it does cave in. I'm not going to ask that, but it's convex. Sorry, concave. And it's an octagon. I'm not going to ask concave, convex. But it's an octagon. Octagon's 8. You do.
Non-sided figure here.
I'm not going to ask that. Nonagon. Not nonagon, yeah. But for those who watch MMA, you guys know the octagon, UFC. It's got 8 sides, right? So, so it's called the octagon. All right. I used to watch many years ago. I don't watch anymore now. It's too bloody. I got small kids. Anyway, extra angles. Oh, this is a good one. Okay, if that's 125, how much is this guy here? Remember, it forms a linear pair. These out to what?
125.
Well, no, because they form a straight angle.
Five.
That's 55. This one right here. Oh, this is what you're talking about. You're talking about these two. You could do, yeah, you could do that too. Actually, you know what? That's probably better you did that. I was just trying to show a way you could do it if you don't remember, but you remember it. That's great. It's actually better. So x plus 90 equals 125. Is that what you meant? Yeah, that's totally fine. Actually, that's probably more direct. Correct. But if you did this, right, then you could see that, oh, then x has to be 35 regardless. So either way is fine. I don't care. But good. You guys remember the concept. That's good. Okay, there's 3 different elimination problems. I just put like as many as I can. Let's do like a middle one. Okay. This is kind of reasonable, I'd say. What if I multiply top equation by 3? Yeah, because what's going to happen to the y's? They'll cancel out, right? And if I add them up, because -6 plus +6 goes away. So you get -4. Then you got to plug back into either equation, solve for y, which should be, I think, 9. I trust you guys can do the math. I'm not worried about that. But that's what you're going to do. And really, it's just 2 lines that touch. Right? That's really what we're doing. And then write an equation on line. How do you find the slope here?
Like y2 minus
Hmm?
1.
Yeah, so 3 minus 8. Or 8 minus 3, your choice. But if I do 3 minus 8, then what I'm gonna put below? Yeah, so you want to do 6 minus, yeah, 6 plus 4, right? If you want to go in the proper order, so it's -5 up top, 10 down below, slope is -1/2. But then I have to write the equation. I probably prefer you do point slope form. So you do this. So y minus 3 equals -1/2.
So we don't do y equals mx plus b.
Don't ask for it. You can if you want. Don't ask for it. You don't have to. Actually, I think I asked. Yeah, I don't know. It's up to you. Either way, either would be acceptable. The system kind of knows this here. Yeah, and same thing here. So, okay. So, if you go to Schoology, if you click on homework 9 under day 9, you'll be able to find the Delta Math link. You might need to register because I made a separate course for it. I think only 3 of you guys are registered, so you may want to do that. I think Bella and Ali are already registered, but the link is there. Yeah, let's just do some practice for a little bit. Yeah. I'll come around and see if you guys, and you can pick whatever you want to do.